everybody, welcome back. I want to talk about some rational functions and their local and end behavior today. It seems like some students are struggling with that. And so I want to explain what this notation is all about. I want to show you guys how to look at this graph and describe it using this notation. And a quick explanation of vertical and horizontal asymptotes. So unlike polynomial functions, rational functions, their graphs are pretty intense and they can be very kind of going in different directions. So that's why we need more notation to describe that, okay? So let's start first with these vertical asymptotes, which are the dotted lines going up and down here, one of them crossing the x value -1 and the other one the x value +2. So when you want to describe what a vertical asymptote, where it is, we're going to describe it using a line, and you're going to describe it by telling us the x value where it crosses, where that line crosses, okay? So notice this first one here, all the x values on this vertical line have the x value -1, which is why we're going to write the equation for it as being x equals -1. If you were to graph this, just put this equation here on a calculator, it would give you a vertical a line going up and down at -1. And the other asymptote happens at x equaling 2. So we would write x equals 2. And what I want you guys to notice, which we're going to talk about in a little bit, is as the graph starts to approach, the x values of the graph start to approach these x values, the graph is like gravitating towards these vertical lines here, okay? So that's where we use the word asymptote to kind of describe that it's kind of approaching it the closer you get. And then we have a horizontal asymptote, which is this sideways line crossing at y equals -3. And just like vertical asymptote, you're going to describe it using the equation describing that all the y values of those points here, they're all going to be at -3. So that's exactly how we're going to describe this horizontal asymptote. We're going to say it's happening at y equaling -3. Okay? So these are the asymptotes, and you want to be able to identify them. And then once you do that, you then want to be able to use this notation to describe the behavior that's caused by these asymptotes. So if we look, let's start off with some notation that we talked about before that was used for polynomial end behavior. And remember that x approaching -infinity was telling us what's happening to the graph as you go all the way towards the left, right? So as the x values start approaching -infinity, they get more infinitely negative. So that's exactly what you want to do with this graph. You want to ignore everything on this side and just focus your attention on what's happening to the leftmost part of the graph. And notice that as x goes to -infinity, the points on this graph, the x values keep decreasing, they get more negative. But you want to analyze what are the y values doing, because that's what the homework's going to be asking you, is what are the output values going to be approaching. So this graph doesn't just keep going down. That's the importance of this horizontal notation, horizontal asymptote notation. It's telling you that as the x values keep decreasing and they keep getting more negative, right, the y values are getting closer and closer to the y value of the horizontal asymptote. So in this case, you won't say that the y values are going down to -infinity, because that's not true. The graph just keeps getting closer to this horizontal asymptote. So the y values of the graph are getting closer and closer to the y value -3. So we're going to say it's approaching the y value -3. Then when we look at x approaching +infinity, remember that means you want to look at the rightmost part of the graph and ask yourself, what's going on as my x values keep increasing? What are my y values doing? Again, my graph is not going to keep going down. I want to know, what are my y values going to be doing? Just like this side, notice that as your x values keep increasing, the y values are getting closer and closer and closer to the y value -3. So we're going to say it approaches the y value negative 3. Okay? So notice that unlike polynomials, this time the y values, the output values are approaching a number versus just going to positive and negative infinity. It won't be the case in this example. Now I want to talk about this section here. So notice that this is what's referred to as the end behavior, because you're analyzing what's happening towards the ends of the graph. Local behavior is what's going on around like the middle part of the graph. So I want to talk about this notation with the little pluses and the little minuses on top of the numbers. So let me show you. Let me grab this guy here, and let's bring it down here, and let's talk about that. So it's saying x is approaching 2, and there's a little plus symbol here. So in this case, imagine you're walking, your x values are approaching positive 2, right? You're zooming into 2. But you don't want to look at it from both directions. This is telling you, I want you to approach 2, analyze what's happening as you get closer to 2, but this you would read from the right side. So what's going on as you're approaching positive 2, but you're coming from the right side? So what does that mean? Remember, ultimately you're being asked, what are the y values doing? As the x values are approaching 2 from the right side. So what you would do is you would say, okay, I'm approaching 2, and my points, the x values of my points are approaching positive 2 from the right. So as they keep getting closer and closer and closer, what are my y values doing? Notice that your y values are going to keep going up and up and up. Your graph keeps going up, so we're going to say that the y values keep increasing, so we write that they go towards positive infinity. Now, for this one, you're being asked, what are as you approach x, as x approaches 2, but now you would read this not from the right side, but from the left side. So as you approach positive 2 from the left side, notice that now you're going to be looking at points from the left side of 2, but you're getting closer to 2. You keep zooming in towards 2. Then you ask yourself, what are my y values doing? Well, as I keep approaching positive 2 from the left, notice that your graph keeps going up. So that means that your y values are going to keep increasing, so they're going to go towards positive infinity as well. Now let's take a look at this one here at negative 1. So now we're going to be looking at this vertical asymptote. Notice that this one was talking about the behavior towards, as you approach this vertical asymptote, this guy is analyzing the behavior as you're approaching this asymptote, from either direction. So let's see. I want to approach negative 1. Here's negative 1. And I want to approach it from the right. So I'm zooming in towards negative 1, but I'm coming from the right. From the right, that's this part of the graph that's going down. So notice that as my points get closer, and the x values get closer and closer to negative 1 from the right, my graph is going down. So that's telling me that my y values are now approaching negative infinity because my graph is going down. So I would say as x approaches negative 1 from the right, the output values keep decreasing, 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 and they just keep going down forever. So they go toward negative infinity. But now, when you want to analyze what happens when x approaches negative 1, but from the left side, now you want to analyze what are these y values doing. Notice that as you approach negative 1 from the left side, you're going this way, your points, the x values get closer and closer to negative 1 from the left, but notice that your graph is going up, which means that the y values keep increasing infinitely, and they never stop. So we're going to say that the output values go towards positive infinity. So a couple things to notice is, again, when you read this notation, the x values are approaching the number. They're not going away from the number. So don't think of this as saying, I start at 2 and I walk towards the right. That's the opposite. This means like you're zooming in. So you're walking towards 2, but from which direction? From the right side. You're approaching 2. And then the other thing to notice is that for vertical asymptotes, because your graphs are going to be going either up or down, notice that for vertical asymptotes, like what we had here, your y values are going to be either approaching positive or negative infinity because the graphs have to go up or down when you approach a vertical asymptote. But for a horizontal asymptote, that was this guy here. Notice that your graph, the y values, don't approach infinity or negative infinity. For a horizontal asymptote, they're approaching the actual y value of that horizontal asymptote. So in this case, the output values are approaching the y value of that horizontal asymptote. Okay, so make sure you keep that in mind. I hope you guys found this helpful. Thank you so much. Have a great rest of your day.